questions from D and F block elements. Today's important questions from potassium permanganate. In our last class, we have gone through potassium dichromate. How much importance for the weightage of potassium dichromate, the same weightage for potassium permanganate also. Here also they will ask a preparation, important reaction, oxidizing properties and the structure also they will ask both. Okay, now let us go for that each and every point clearly. Now first and foremost we are going to learn the preparation of potassium permanganate. Okay, how do we prepare that? There are two steps are there. First step, from ore converted into potassium manganate. Then second step, potassium manganate through oxidation process, potassium manganate converted into potassium permanganate. Okay, first one, ore. No, what is the name of the ore? Pyrolusite. Pyrolusite, it is nothing, manganese ore only, MnO2. So this is converted into potassium manganate. MnO4, K2MnO4. Please note that. Okay, now the second step, K2MnO4 converted into KMnO4. This is what we want, right? You got it? Okay, now let us go for the process. Now, first step here, MnO2 combined with the caustic potash, KOH, along with oxygen while heating, you will get K2MnO4. Not only with caustic potash, even it may react with K2CO3 along with oxygen in the presence of air also we can say, or else KOH, that is potassium hydroxide, along with oxidizing agent like potassium nitrate or potassium chlorate. So here KNO3. KNO3. Here also you will get the same product. These are all different reactions for the first step only, right? K2MnO4. Here also K2MnO4. So here the reactant are same, MnO2. Manganese dioxide, MnO2. Okay, now the first one. Here MnO2 plus KOH plus oxygen, you will get K2MnO4 plus H2O. Now balancing that equation K2, no? So if we put it 2, here also 2, and here Mn. So naturally you will get it here 2. So then here also 2. Right? Now the second one, here carbon dioxide, carbonate, no? So definitely carbon dioxide will be coming. So here you will get K2, no? Here also 2. This 2. This also 2. So manganese and here carbon dioxide. Okay, now here in this KOH plus KNO2 plus H2O. Right? Now here K2. Here also. Okay, now this process, these are all different reactions. So you will get what it is? Green mass. Green mass product, like you will get it. That is what it is, potassium manganate. Now this potassium manganate treated with water, that means washed with water, you will get green color solution. Now the second step we are going. So the green color solution reacts with chlorine or else reacts with oxidizing agent. You will get what it is, the pure potassium permanganate, purple color crystals, like you will get it. Come on, let us go for it. As we got the product of potassium manganate extracted with water and treated with current of chlorine, you will get potassium permanganate. Another one more type. Potassium manganate reacts with ozone along with water. You will get potassium permanganate. And also it reacts with carbon dioxide. You will get what it is, potassium permanganate. Come on, let us go for the first one. K2MnO4 along with chlorine. You will get KCl plus KMnO4. This is what we want. Yes, here KK, here also 2, here also, and here also 2. Yes, we got it. Right? Now the second one, KMK2, MnO4, along with ozone and water. So you will get KOH plus KMnO4 plus oxygen. Right? So here you will get 2, here also 4, right? 2, 2, right? And O2. And the same way here, third one, K2MnO4 plus CO2, carbon dioxide. So you will get what it is? K2CO3 plus KMnO4 MnO2. Right? Okay, now here K2 and K. So 3 and here 2. So here you will get what it is? 6, right? So 2, 4 and here 2. Yeah, 6. You got it. Okay. I hope you got a clear idea about these three things. And the first step it is pyrolusite converted into potassium manganate. Second step, potassium manganate into potassium permanganate. Okay. Now, any one equation from that above one equation and below one equation, you can write it for these two process. These are all ideas I just bring it to you. Okay, another one more method it is there, that is for electrolytic method. Now we'll go for that electrolytic method. How do we prepare that potassium permanganate? Electrolytic method, it is so simple. You know, potassium manganate converted into potassium permanganate. So in the electrolytic cell, what we have taken? K2MnO4. So what is there in that cathode? What is there in that anode? Before going for this cathode and anode, let us go for that. What is there? Alkaline oxidative fusion of MnO2 followed by the electrolytic oxidation of manganate. So MnO2 is fused with the KOH and oxidized with the KNO3. That's all. These are the three main things: MnO2, KOH, and KNO3. So this converted into MnO4 2 minus. So this alkaline solution electrically oxidized to get permanganate ion. Right? Okay. Now electrolytic cell, what it is there? K2MnO4. At cathode, here iron rod we have taken, at anode nickel rod we have taken. So what happened? This potassium manganate. So here MnO4 minus converted into MnO4. Here 2 minus, here 1 minus. That means here plus 6 oxidation number. Here plus 7 oxidation number. Right? Okay. Now here what happened at anode? 2H plus ion plus 2 electron, it gives 2H. Okay, this is very simple and it is also important. Okay, now we are going to see the important reactions related to that topic. While heating, potassium permanganate while heating, what happened? Potassium manganate, you will get it. Okay, along with MnO2 plus O2 oxygen, you will get it. Okay, so here K2, no, here. So you will get it, what it is? K2 MnO4 plus MnO2 plus oxygen while heating. Now again it decomposes. K2 MnO4 decomposes to K2 MnO3 plus oxygen. Right? Okay, now here. So this is potassium manganate. This is potassium manganite. Please remember that. Okay, now this is over. Now another one, action on alkalis, that is caustic potash. Okay, so KMnO4 it is K2MnO4 plus H2O plus O2. So here to balance this is 4. If we put it means 8, so you will get it here. 4 twos are 8, and remaining H2 here 2. So all together, yeah. So potassium permanganate reacts with potassium hydroxide, you will get potassium manganate. Hope you're clear with it. Now another one more important point, which is oxidizing property, which is very very important. Let us go for that oxidizing property. Now let us go for the oxidizing character of KMnO4. Now this manganese only is the main point we have to consider. So manganese atomic number, right? Atomic number 25. Electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. Outermost orbital 7 electrons are available. Yes. Okay. Now KMnO4 oxidation number we have to find out. Now oxidation number K, it is +1 because it's a first group element, and Mn plus X plus 4 into -2 equal to 0. So +1 plus X minus 8 equal to 0. So 1X minus 8 equal to 0. So X equal to +7. Right? So Mn, what is the oxidation number? +7. KMnO4, it can provide only 7 electrons in the outermost orbital. So oxidation process will be nil. Why? Because outermost orbital 7 electrons only there. Rest of that and all, it is completely filled. That is AR 4s2 3d5, right? So only outermost orbital, how many electrons are remaining, that only it can provide. So oxidation power, it is nil. But reduction process, it reduces itself and helps other elements to oxidize in a better way. So reduction process, and it reduces itself, and actually it is a strong oxidizing agent. Oxidizing agent. Right? Okay. Now, it's a very good oxidizing agent in acidic, basic and strong alkaline. All those mediums, let us watch. Now, first and foremost, acidic medium. Acidic medium. Okay, acidic medium, what happens here? KMnO4 plus H2SO4. I just mentioned here MnO4 minus. It gives Mn2 plus. Right? Okay, now we'll write this equation as well as simultaneously we'll write this equation. So here K2SO4 MnSO4 H2O plus O. Nascent oxygen. You will get what it is? Nascent oxygen. Okay, now here, as I mentioned redox reaction in our last video, how to balance the redox reaction, I just mentioned a clear idea. Please watch that so that you will come to know very clearly. How many oxygens are there? Right hand side, you have to put that many water molecules. That means 4H2O. Now, how many hydrogen is available? That many H plus ion you should put it in the left hand side. So that means 8, right? 8 H plus ion. 8 H plus ion. Now, how many electrons have exchanged? Here what it is? Here it is +7 and here +2. So how many electrons in between? 5 electrons change. So here 5 electron. Right? So number of electrons change. So this is the way. Now you balance this equation 2, right? So 2 and 3H2O. Here K2SO4, 2MnSO4, right? 3H2O and 5O. So this is the acidic medium equation and this is the redox reaction point. Hope you're clear with that acidic medium, what it is. If you want, you can take that screenshot how to write that balancing equation. Please watch that in our last video. Please check that I have given a clear idea about all those hints, right hand side, left hand side, what are the points to be taken. Hope you're clear with it. Okay, now we are going to see the basic medium, how it is giving that product. Okay, now, this is the acidic medium we have seen. Now we are going to see the basic medium. Now, in this basic medium, KMnO4 combined with the water, you will get MnO2 plus KOH plus nascent oxygen. Okay, so here 2 KMnO4 means here 2 MnO2, 2 KOH and 3 nascent oxygen. So here MnO4 minus, it reduces to MnO2, right? Now in this is a basic medium, right? So here how many O4 minus, it is 4OH minus, like that we can write it, because how many oxygen, that much OH minus ion. Now in that way, another point, how many number of hydrogen, here 2H2O water molecules, in that way half we can write it. Okay, now reduces, this is what it is. Here how many electrons are available? Here 7 oxidation number, here plus 4 oxidation number. So that means how many electrons can exchange, means 3 electron. So here plus 3. So why I am giving all this, equivalent mass also we have to consider. So how to find out that equivalent mass? As I mentioned here, equivalent mass equal to molecular mass divided by number of electron change. Because each one, acidic medium, basic medium, number of electrons will be changing. Here 5 electron, here 3 electron. That's what I mentioned purposely here. So what is that in acidic medium? What is that? Here molecular mass divided by 5 electron. Whereas here equivalent mass equal to molecular mass divided by how many electrons here change? Here 3 electrons, right? So this is the way you have to write it. And next one, alkaline medium. We are going to see the alkaline medium also. So alkaline medium, what happens? Here, alkaline medium KMnO4 plus KOH. It gives K2MnO4 plus H2O plus nascent oxygen. Okay, here K2, right? So here we can put it 2, here we can put it 2. So to balance that, here 2. 2 into 2, 4, right? Okay, now in this MnO4 minus, it can provide MnO4 2 minus. Okay, now here what it is, what is the oxidation state from here to here? How many electrons can be available? Now you just check it here, X plus 4 minus 2, right? Equal to minus 2. So that means minus 8. Minus 8 equal to minus 2. So that means plus 6 oxidation state. Whereas here X plus 4 into minus 2 equal to minus 1, right? So that means minus 8 equal to minus 1. So here plus 7 oxidation state. So here plus 7 oxidation turns into plus 6 oxidation. So that means How many electrons can exchange? Only one electron. So equivalent mass equal to how much it is? Molecular mass divided by 1. So what is the molecular mass? Right. 158 divided by here 5 and here 158 divided by 3, 158 divided by 1. Hope you're clear with it. Okay, now why I have given acidic medium, basic medium and alkaline medium? Because sums will be available how we have gone through potassium dichromate. Like that here also there will be 3 marks questions will be there. Now let us go and check it with those sums. Now let us solve this problem. KMnO4 acidifies Fe2 plus 2 Fe3 plus ion. How to write the equation? Acidic medium. Okay, they have given the fixed equation 2 KMnO4 plus 3 H2SO4 gives K2SO4 2 MnSO4 3 H2O and 5O. This is acidic medium. Last point only we have gone through this. Okay, now let us go for it. Here FeSO4 plus H2SO4 plus oxygen. It gives FeSO4 thrice plus H2O. Okay, now how many electrons involved in acidic medium? We are thinking that this is acidic medium only. So here a number of electrons involved in acidic medium means 5 electrons only, right? So multiply with 5 electron. Why we are multiplying? To compensate, equalize. For that is the reason. Okay, now here balancing equation here 2 FeSO4. Why? Because Fe2SO4 thrice ferric sulfate. Okay, now you have to multiply with that 5. So 5 twos are here 10 FeSO4. Here also what it is? Here 5. Here 5 twos are 10, right? So here 5. Then what it is? Here also 5 and here also 5 and here also 5. Right? Now write this full complete equation. 2 KMnO4 plus 3 plus 5. 8 H2SO4 plus 10 FeSO4. Here 5 twos are 10, right? That's what I just put it 10. Okay. Then it gives here 5O cancel, right? Okay. Now here K2SO4 plus 2MnSO4 plus 3 plus 5 8 H2O plus here what it is 5 Fe2SO4 thrice. That means Fe3 plus 10 Fe3 plus 5 twos are 10, right? Okay, now this is a complete equation. We can write it another way. MnO4 minus it gives Mn2 plus. So here what it is 2 MnO4, here the same. Okay, how many oxygens are there? 4. 4 twos are 8. So 8 H2O. Right? How many hydrogens are there? That many H plus ion. So that means 8 twos are 16 H plus ion. Okay, now how many electrons can involve? 5 electrons. Here it is actually what it is. 5 twos are 10. So 10 Fe2 plus. 10 Fe2 plus. It converted to 10 Fe3 plus. That's all. This is the skeletal structure of redox reaction related to this equation. Hope you're clear with this, or else you can write it this also here. MnO4 minus it gives Mn2 plus. Right here 2. Here also 2. So here how many oxygens are there? That many water molecules. H2O, 8 H2O. Last video I have given a clear idea how many number of oxygen? that many water molecules you have to write it in right hand side. How many hydrogen is available in that right hand side? You have to write it that many H plus ion in the left hand side. So that means 16 H plus ion. And this is the top equation. This point. Okay. Now this is the skeletal structure of what it is, redox reaction, and this is a complete equation of redox reaction. Suppose if they are providing this, you can write this also, or else you can write this also. Okay, now 16 and Fe plus you have to add from here only. Fe 2 plus to Fe 3 plus. Okay, how many electrons can involved means 5 electron. So 5 electrons means here 5 twos are 10. Here 2 it is there, no? So here 5 twos are 10 to compensate in that way. Hope you're clear with this. Okay, we'll go for some other equation. Now another one more equation. KMnO4 acidified with potassium iodide to iodine. This is so simple. Already we have gone through, right? So here KMnO4 plus H2SO4. It gives K2SO4 plus MnSO4 plus H2O plus 5O oxygen. Right? So here 2 KMnO4, 3 H2O, 2 MnSO4, 3 H2O. It's a fixed reaction. Now, acidified potassium iodide. So, potassium iodide Ki plus H2SO4 plus oxygen. It gives K2SO4 plus I2 plus water molecules. Right? Okay. Now here what it is K2, right? So 2 K2SO4, H2SO4, H2SO4 and oxygen H2O. Okay. Now you have to multiply with how many number of electrons are here involved means 5 electrons. Please remember that. So multiply with 5 electron. So if you multiply with 5 electron means here 5 twos are 10 and here 5 and here 5. So here also 5 and here also 5 and here 5. Right? Okay. Now let us write the complete equation. So 2 KMnO4 plus 8 H2SO4 plus 10 Ki. This 5O and this 5O will be cancelled. Right? Now 5 K2SO4 plus this is 1. So 6 K2SO4. Please note down. Then 5 I2 plus 2 MnSO4 plus 3 plus 5. 8 H2O. Right? This is the complete equation. Now, how to write the ionic equation of this? Right? Okay, now here 2MnO4 minus, it gives 2Mn2 plus. How many oxygens are available? 4. 4 twos are 8. So that means 8 H2O. How many H plus ion, H plus hydrogen molecule is available? That much H plus ion. So 8 twos are 16 H plus ion. Okay, now here 10 I minus plus 10 I minus. Here, what it is? 5I2. You can ask, ma'am, 5I2. 5 twos are 10. That's all. Okay, now here also we can provide here in this 2MnO4 minus. It can provide here 2Mn2 plus. Right? Okay, now here what it is? 8 H2O. 4 2s are 8 H2O. Now that means here 16 H plus ion, and here how many electrons involved? 5 electrons involved. So here 5 electrons. So in this way you can write it. Okay. Now here also you can write 2I minus. It gives I2. Like this you can write it. Ionic equation. Hope you're clear with this part also. Okay. So like that you just get a good idea about that equation, then it will be easy. Actually this is 3 more questions they will ask. Okay, one they will provide, other thing you have to find out, or else they will give only this. You know what is the fixed reaction. Before entering into this only you will come to know very clear idea about what is the rules for the redox reaction. In my last video you please go and check it, complete idea I have given the tips and tricks for you. Okay, hope you understand. Okay, we'll go for some other question. Now let us see this equation. KMnO4 oxidizes hydrogen sulfide to sulfur. Oxidizes acidic medium. Okay, come on, let us go for to solve this equation. KMnO4 plus H2SO4. It gives K2SO4 plus MnSO4 plus H2O plus 5O oxygen. Right? Okay, now here 2 KMnO4, 3 H2O. Here 2 MnSO4 plus 3 H2O, yes, 5O. Right? Now how to write this equation? Hydrogen sulfide. Hydrogen sulfide H2, yes, plus oxygen. It gives H2O plus sulfur. Okay, now this, how many electrons involved? 5 electrons involved. So to compensate, you have to multiply with 5 electrons. So 5 electrons, if you multiply, means you will get what it is, 5 H2O, 5O, and here 5 H2, H2, yes, sorry, H2, yes, and H2O, and here 5 yes. And this one and this one cancelled, right? Okay, now write the complete equation. 2KMnO4 plus 3H2SO4 plus 5H2S. It gives K2SO4 plus 2MnSO4 plus 8H2O. See here 3 and here 5. 8H2O plus 5. Yes. Right? Everything have written. Yes. K2 Mn H2O. Yes. Yeah. Okay. Now ionic equation how to write means MnO4 minus, that is 2. It gives 2 Mn2 plus. How many oxygen? According to that, you have to write water molecules. How many here? 4. 4 twos are 8. How many hydrogen? According to that, you have to write what it is? H plus ion. And here 5. 5. Yes, 2 minus. Here you will get 5. Yes, 2. Right? Yes. 5 yes, 2. Right. Sorry. 5 yes. Hope you're clear with this. Okay. Now this is the way you have to write ionic equation. Now, we are going to see neutral medium, the same equation, the side, hydrogen sulfide only. Let us go for the neutral medium, right? Now, let us check with that neutral medium. KMnO4 plus H2O. It gives KOH plus MnO2 plus oxygen. Right? Here, in this 2 KMnO4, here 2 KOH and 2 MnO2 plus 3 oxygen. Okay, now KMnO4 oxidizes hydrogen sulfide to sulfur. So hydrogen sulfide H2, yes, plus oxygen, nascent oxygen, it gives H2O plus sulfur. Okay, now this is a neutral medium. How many electrons involved? According to that, you have to multiply with that many electrons, right? To compensate, to equalize that equation. So, what is that? Here 3 and here also 3, here also 3 and here also 3. Now write the complete equation. 2KMnO4 plus 3H2S plus here water molecules, here water molecules. Yes, this and this will be cancelled, and it gives 2KOH plus 2MnO2 plus 3H2O here. So 2H2O plus 3S. Okay, now we have to write that ionic equation. Here 2MnO4 minus plus, yeah, we'll write this one 2MnO2, and here how many? According to this 3H2S, and here what it is? How many oxygen? According to that water molecule. So 2H2O plus 2OH minus, and here 3 sulfur. 3 sulfur. Right? Hope you're clear with this ionic equation. Here OH minus ion, which I have written because neutral medium. Acid and base, neutral medium. That is what I have written. Hope you're clear with this. Okay, now we are going to see that structure of MnO4. Now, tetrahedral shape. Tetrahedrally, oxygen atom is around that manganese. Okay, so this is manganese in that. Okay, so here double bond and here O minus. So this is tetrahedral shape. Whereas another one, this is what it is. MnO4 minus. Right? Permanganate. Here the same way here. Double bond O, here O and here single bond O. Okay. So this is manganate ion. MnO4 2 minus. Hope you're clear with it. Okay, now in our last video we have not done that structure of potassium dichromate. This is potassium permanganate. Potassium dichromate structure. Let us watch. Now we are going to see the shape of the chromate ion and the dichromate ion. Actually, shapes, definitely they will ask the shapes of chromate ion, dichromate ion, permanganate ion, manganate ion. These are all expected questions. That's what I am giving. Okay, now chromium ion, which is connected with oxygen tetrahedrally. Here oxygen O minus. So here tetrahedrally. Okay, so CrO4 2 minus. Right? Now next one, dichromate ion. Here Cr, which is connected with oxygen, and here one more oxygen, here Cr. So here two tetrahedral shapes sharing two corners of CrO-Cr. So CrO-Cr bond angle, it is 120 degree. So here one double bond, here one double bond, the same way. Here one double bond, here one double bond O, and here also O. So this is actually Cr2O7 2 minus. Right? Here one minus, here one minus. Hope you're clear. Okay, now in this bond angle, here from here to here, this is 179 picometer. This is from here to here 166 picometer. So these are all expected questions. You can expect these questions and all whatever I have given in this videos, like all playlist you are having, just to go through all those questions, all important and expected questions only I'm providing for you, because D and F block elements are full and full, completely informative, and there are so many questions are available. Like redox reaction also interrelated. Like physical chemistry and inorganic chemistry both are interrelated, interconnected. So that's what I'm just bringing all these points to you. Hope you understand clearly. Thanks for watching, and please subscribe this channel so that you will get all the notification.